All right, everyone, welcome to the third lesson of the Artificial Intelligence webinar series. Today, we're going to be doing a continuation of last week's session with machine learning algorithms, but we'll also be starting our very first machine learning project with actual coding by the end of today. So today's going to be a very exciting lesson, and then we'll continue with the coding project next week as well, and we'll leave you with some homework to work on throughout this week as well. All right, so just for the rules, just reiterating on them, remember to stay muted. If you have any questions, you may ask questions in the chat, especially when we're doing coding today. If you find any errors in your code or if you're not able to catch up or keep up, just let us know through the chat and we'll let you know how to fix your problems. Then what we'll do is we'll count, you have to make sure that you fill out the Google form. So I'll go ahead and send out the Google form right now in the chat. Yes, I will be sending the Google form in the chat. And this Google form, it should be open. And please make sure to fill that out. You only need to fill it out once. We will receive it as soon as you press submit, and that will be a way to make sure that you are counted for attendance for the certificate later on. So again, the certificate will be sent at the end of the lessons, and if you attended all lessons, you'll be given a certificate. Okay, since students are still trying to enter. All right. So just really quick over the agenda. As I mentioned earlier, we'll be going over machine learning algorithms, the continued version of it. So last week we went through all the way up to support vector machines. And today we'll be finishing it off with the decision trees algorithm and Gaussian naive Bayes or just naive Bayes. And then what we'll do is we'll be starting coding with a machine learning project, which is a classification project. And we'll talk about the premise of what we're trying to classify once we get to the project. All right, so what we'll do is we will get started with our very first machine learning algorithm.
All right, so our first machine learning algorithm that we will be speaking about today are decision trees. So just like the other algorithms we spoke about last week, this is another classification algorithm. All right. So this is just a simple example of what a decision tree might look like. Look at this little graphic on the right. We can visualize any decision tree given in the format on the left, like the right side. So what we're basically doing is asking a question, which can then give a yes or no answer. And a lot of times with data, it would be greater than or less than a specific value. And that will lead to either another question or a classification. Another example of a decision tree, as we can see here, similar to the last one, I just want to now point out some of the more specific parts of this. So looking at the left graphic, we can see that the homeowner, marital status, both of those are categorical, which means that there are specific categories that those might be. And then there's also the annual income, which is continuous. Basically, what this means is that it can be any value in a range of values. Other examples of continuous variables might be height or weight. And then the class is also something that's necessary. Whenever we're doing classification, let's remember this term, supervised learning. It means that we're given the labels ahead of time, and in this case, that would be the classification, the defaulted borrower. And so that would give us a classification of no or yes in this case. And so then we look on the right. And so we could go through this decision tree, which was created using the type of data given on the left. And then we could give a classification of whether or not we think that the borrower is going to default or not. So the first thing we would ask is this person married or not? If they are married, then we'll say no, they're not going to default. But if they're single or divorced, then we're going to go to another question. And then so on and so forth. Are they a homeowner? Yes, then we're not going to assume that they'll default on a loan. And then if they're not a homeowner, then we're going to look at their income. And so essentially, you might say that the marital status is the first split, then the homeowner would be the second split, and income would be the last split.
All right, so now what we're going to do is we're going to take this model. So for example, let's say we've created a model of decision trees that looks like this, okay? And so now we're going to apply it to test data, okay? So now what I'll do is I'll make sure to ask you questions. And if you could write in the chat which side of the decision tree this certain test data would go on, if you could put that in the chat, that would be great. So let's start from the root of the tree. Okay, so from the root of the tree, we are asking whether this person is a homeowner or not. So which one will be going through here? Will we go to this side here, or will we go to this side? You could say left or right, whichever one it is. So based on the test data that we have here of homeowner, will it go to the left side of the tree or the right side of the tree? You can just put in the chat left or right. Okay, so we have a couple of answers. Let's wait for a few more answers. Again, the question is based on the test data here, will it go to the left side or the right side? Okay, so we have majority of the answers are correct, so it will go to the right side. The reason for this is because we have homeowner as no. So the test data says no, right? So based on this decision tree that we have here, is this person a homeowner? Yes or no? No, right? We are told that this is not a homeowner, so we go to the side that says no. This might have been a little bit misleading because you'll see a no here, but that is only if it'll only say no if the homeowner is yes. So basically what you're trying to find is whether this person, if we go back to our example here, we're trying to figure out whether this person is a defaulted borrower or not. And so what we have to do is we have to here, if they are a homeowner, then that means they are not a defaulted borrower is what it's trying to say. But the reason why we go to the right side is because they are not a homeowner. And so when we're asking the question, is this person a homeowner? We have to go to the right side because the answer is no on that side. All right, so overall, we're doing pretty good now. Okay, so right side, yes. And so you'll see here, based on the homeowner information, we now see that this is not a homeowner. So we can go here, homeowner, we correspond to this place here, and it's no. So we'll go to the next slide and it says no, right? So that means we now need to check for their marital status. If it said yes, we didn't have to check anything else and it would already default say, no, they are not a defaulted borrower. Okay, so now the next question is on this marital status. So which side would this go on? Would it go to the left side or the right side, depending on what information we have here in the test data? Would the decision tree go to the left or would it go to the right? Right side again. Great job, everyone. So yes, so what we see here is that now we're checking and corresponding to the marital status. So if it said single or divorced, it would go to this left side and then check for another thing, right? Income statement. But what we have here is that it says that if this person is married, then we just have to go here. So what we see is that they are married. So now we will just go here and now it is the end of the decision tree, right? There's no other question here, right? So it says no. But then so this means that it will classify this particular test data as not a defaulted borrower. So what we see here is that it is not a defaulted borrower here. So assign defaulted to no. So that's the class that it will be assigned to. But if I were to have a let's say, for example, if this test data said not a homeowner, so it would be here, but let's say the marital status was single or divorced, right? So then it would go here, and then we would have to consider what the annual income is. But now, because they are married, we don't need to consider the income statement, so we don't even need to look at that. And so here we have a decision tree. So the idea is that based on a bunch of training data that's given, the model here, which is this decision tree here, has to be tried out many times to figure out which features basically show that they are a defaulted borrower. So here, what this decision tree is saying is that if they're not a homeowner and they're married, then they're most likely not a defaulted browser or borrower, sorry. But then if they are a homeowner, they're automatically not a defaulted borrower. So like that, you have to see. And then what's the main idea here that, so if they are a defaulted borrower, the only way they are is that if they are not a homeowner, if they are single and divorced, and if they have a income statement over 80K annual income. And so that's the only way that they will be a defaulted borrower. So that's the main idea that we want to get or communicate with this entire idea of a decision tree, that there's a certain path that it will have to take to be able to get a certain class in the end. All right, so yes, it's very similar to a flowchart.
All right, so now let's talk more specifically about how these decision trees are built. So the first thing that we want to go over is how we split our data. So the process of partitioning the data set into subsets is what we call specifically splitting. And so we need to look at our data, and generally what we're going to look at is how much information we can gain by creating each split. The reason that homeowner would probably be our first split is because we noticed that when we split at homeowner, there seemed to be a more clear classification of the types of data than at any of the other points. And so pretend that we had 50 data points. 26 of the people are 26 of the people are not homeowners, and 24 of the people are homeowners. Of the 26 people that are not homeowners, about half of them are going to default on their loan. But out of the people who are homeowners, every single person except one happens to not default on their loan. However, with marital status, it might not have been so easy to see the difference. With marital status, of these 50 points, we might have noticed that 25 were married and 25 were single or divorced, but it didn't correspond as tightly with whether or not they would default on their loan. And so therefore, we want to use homeowner as our first split because it gives us a more definitive split. This is called information gain. And so our first split will be decided by which split along which column will give us the most information. All right, and so the next thing we want to go over is pruning. So this essentially is the simplification of these decision trees by removing sections of the tree that provide little power to actually classify. What we might notice looking at this tree pruning example is that when income is less than 30K, it seems that we might have data that would have created the tree initially on the left side. And so we might have had a few data points that had a criminal record. So we might have had a few points that had a criminal record, and out of those, all of these other categories were still existing. Had some different points. And so say that we had a group of 100 points, and 30 let's not use the same number. 40 of those points have income less than 30K. But of those 40 points, about 35 of those points would default on their loan. So even though it might be true that 5 of those points would have been better classified using the tree on the left, it's easier and would take less work to just use the tree on the right and say that all 40 of those people would probably default in their loan. So using this example, there are obviously real repercussions to this in the real world, in that many people may not get a loan when they could probably would pay for it. But this does reduce complexity and overfitting. And so if you remember what overfitting is when our data starts, when our model starts to memorize our data, and we don't want that. And so in the case that I mentioned, there are 40 points with less than 30K income, but 5 of those points would do the loan and 35 would not finish the loan. Then we want to simplify that so we don't overfit to those 5 points.
All right, so now for our next aspect of decision trees is the key factors in creating splits. So as Neha mentioned before, information gain is one of the most important things to understand in decision trees. So this is a great graphic on this topic here. So information gain is essentially this. When you split between a certain thing, you want to make sure that you're actually gaining some information from it, right? You want to make sure you're actually learning something from it. So based on these tests, let's first describe what these tests are, and then I'll let you guys choose which one do you think is more informative. So this one take some data points. So green points are one certain class, and the red crosses or the red dots are the ones that are in another class, basically. And so the idea is that you want to separate these classes, right? So that it can tell you as much information as possible. So here we have a split over whether the balance exceeds 50K. So if it's less or equal to 50K, these are the points, this is the line that we are drawing. So these are the people who are less or equal to 50K, and these are the people over 50K. Here, however, it says split over whether applicant is employed. So unemployed will be on this side, and then employed will be on this side. So which of these are tests? The left side or the right side, or you can say the balance or the employment, whichever way you would like, but tell me which test do you think is more informative? You could just say left or right, or whichever one is most important. You could put it in the chat. And so let me know which one is more informative, the left side or the right side. Let's get some answers going on in the chat. Again, information gain is the way of, am I getting the information that I need to be able to split these classes? And I'll once we get the answer, I'll let you guys know why it is this. Okay, I think it's the right side. All right, we see a lot of right sides here, and you guys are correct. So great job. And we'll go over why. Okay, the most important thing, that more than getting the correct answer, is the reason why, right? We want to be able to understand why this test right here is more informative. What we see here is that, let's say here we've made this wonderful split, this wonderful line here. But what you'll see is that there's some green points here, but then there's one red point here. But then this side is even worse, right? We have a bunch of green points in a place where there's a lot of red points. So if I were given a new test data, let's say if I were to give a point here, okay, if I were to give a new point here and I were to ask the program, is this a red class or a green class point? The program has no idea, because technically there are some green points, so it could be a green point, but there are a lot of red points, so it could be a red point. So there's a lot of confusion there, you see, and we don't want the algorithm to be confused, right? We want it to be able to create a very firm answer. And so that's what we have on the right side here. On the right side here, what you'll see is that we have a very definitive answer, right? If I'm on this side, what class would it be? Would it be green or red? The algorithm is very clear, like, okay, there's everyone on this side. So on this side of the line, everyone is green. So this it has to be the green class. And then on this side, everyone's in the red class. So let's put this point in the red class. So you see how it gives so much more information when we split it over the whether the applicant is employed or not employed, rather than the balance exceeding 50K, because here there's a lot more confusion as to which class this point will be in. Okay, so what I'll do is I'll give another example of this. This one is not going to be as clear, but you'll see here that here we have a low information gain and a high information gain. But what you'll see here is that this is different from what we saw earlier, right? What we saw earlier was like for the high information gain, the one that was more, the one that gave more information, like for example, let me show here. So here, what we had for the high information gain one, it's like a very clear distinction between which is green and which one is red. But here, what we see is different, right? So let's say we have the green class and the red class, okay? And the reason why this one is low information gain is we'll see here. So I'll sort of label the green ones with the letter G. So we have 5G here, and we have 5R, which is red, here. Here we have the same exact thing. So 5G, and then so 5G right here, and then we also have 5R. Okay, but then so what happens is that if I come to this split, I'm like, okay, so this new test data, should I put it in the green class or the red class? I have no idea, because there's half of the green is sitting there and half of the red is sitting there. So now I have no idea whether I should put it in the green class or the red class. So again, this is why it's low information gain, because I really didn't learn anything from the split, right? Whether I go here or here, I still have no idea whether to put it in the green class or the red class. However, here what we see is that we have 8, I believe, if I counted correctly. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so 8 green and then we have only 2 red, right? And then here we have 8 red, and then we have 2 green. So now it's so much easier for the algorithm, right? Because if I'm on this side, which class am I going to classify it in? I'm going to classify in green because majority of the class is classified as green. But then here, I'm most likely going to be classifying it as a red class because most of the points there are red. So does everyone understand the difference now between low information gain and high information gain? I hope these graphics were able to help. But these are the main ideas behind how it creates the splits, because what we went over earlier is like just how to follow a decision tree, but this is exactly how it's going to create those splits. It's basically going to try all of these different splits. Like, will this split give me information? If not, it's going to go to another type of split. Okay, if split gives me some information, then I'll keep that in the decision tree. So that's what you mainly want to think about. When you're going over these decision trees, you want to make sure that you understand the difference between a low information gain and high information gain. And you have to know that information gain is the main idea that goes behind creating these splits for decision trees. All right, so hopefully that made sense, and let us know if you have any questions in the chat as always. And if not, we'll go on to the next machine learning algorithm.
So this next machine learning algorithm is called naive Bayes. So let's get into what naive Bayes actually is. So in machine learning, naive Bayes classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem, which is where we get naive Bayes from, with strong naive independence assumptions between the features. I'm just going to quickly explain what naive actually means in this situation. So say that what we were creating was something to classify emails as spam or not spam. And then we use specific words. So we'll notice that money tends to show up more often in spam emails, and that the word friend or family shows up more often in normal emails. However, we won't take into account the order of these words. That's why it's considered naive. So if I say friend and then money in an email, it won't give a different probability than if I say money and then friend. So the order will not matter, and that's why we call it naive. And so a lot of this might look a little daunting at first, but all the P means is the probability. So reading this very first part here, the probability of event A, which could be a specific thing, given the event B. And so say that it's, trying to think of an example. Say that one day it's going to be sunny. It's sunny in the morning, and usually that means that it's going to be sunny throughout the day. Event A would be sunny in the morning, and event B would be sunny throughout the day. So event A given event B would probably be quite high, because usually if it's sunny in the morning, it'll stay sunny for the rest of the day. And so the way that we can look at this more simply is that the posterior is equal to the prior times likelihood divided by the evidence. And so don't think too much into this. We're going to look at an example. All right, so pretend it's a picnic day. And so we're going to be planning a picnic, but the morning is cloudy, so we want to know whether or not it's going to rain, because sometimes being cloudy would be indicative that it's going to rain. So first off, we know that 50% of all rainy days start off cloudy. That means that given that it's a rainy day, 50% of the time it starts out cloudy. Therefore, cloudy would have been event A, and rainy would have been event B. All right, but cloudy mornings are common. So about 40% of general days start cloudy. And then this is usually a dry month, and only 3 of 30 days, or 10%, are rainy. So then let's see how this looks when we do the actual math. So what is the chance of rain during the day? So we're going to use rain to mean rain during the day. So if you're looking at the probability statements, rain just means that it's going to rain during the day, and cloud to mean cloudy morning. So the chance of rain given cloud is written in this way. The little line in the middle means given. And so when we put it in the formula, the chance that it's going to rain, given that it's cloudy in the morning, is going to be the probability of rain, which will be 10% because this is a generally dry month. And then the probability of cloud given rain will be about 0.5 because given that it's going to rain, we know that 50% of the time it starts out cloudy. And then the probability that it's just generally cloudy on any day is 40%, and that's right there. So then all of these are transformed into decimals, which we can then calculate below. And so you'll see here that that calculates out to 0.125, which when converted back into a percentage is that there's a 12.5 percentage chance of rain. And so that's what happens in naive Bayes. But this is not all that happens. This is one example of what we're going to do. But going back to the email example that I had just talked a little bit about, we have spam emails and normal emails. What will happen is that we're going to calculate this probability statement for spam emails with whatever specific words we're using, and then do the same calculations with normal emails. So all of the givens will be either spam or normal. And then we'll get something like this 0.125 for each of them, and whichever one has the higher probability is what we'll end up classifying that point as.
All right, so that concludes our lecture about the machine learning algorithms. Just a brief summary or conclusion to that entire lecture, starting from last week. All of those aspects of machine learning algorithms and talking about the theory behind them and the math behind them, it's all for understanding purposes, right? Because we don't want you to just take and import machine learning algorithms and just put them on your project, right? We don't just want you to paste them into your project. We want you to truly understand what is going on inside of these algorithms. So that was really the importance of these lectures that we've been having about these algorithms. And so now what we'll actually be doing is implementing them into a certain project. So again, that was all for the understanding of the algorithm so that you know what is going on in the backend or what is going on when I'm importing this algorithm and using it in my project. So now what we're going to do is we're going to start off with coding a machine learning project. Before we get into coding, however, we want to be able to tell you exactly what we are doing. So what are we doing with this part? What exactly are we coding? So what we are doing is something extremely exciting. We're going to be classifying breast cancer. By the end of this course, you guys will have the expertise to basically do any classification project. And a simple idea that I want to give here is that there's many different features that we have in this data set. And I'll link this data set in the chat in a second. But essentially, the idea is that using a data set that's online, you can research online for data sets anywhere. There's lots of thousands of data sets that you can use. So once you learn the basics of how to code a machine learning project, you can implement this into any data set that you find online that is a classification project. And so just a brief overview of what we'll be doing. The goal is to accurately classify whether a patient has breast cancer or not based on several factors by using the implementation of classification models. Classification models, again, is referring to the classification machine learning algorithms that we just discussed. Okay, so now let's go to this link and I'll show you exactly what I'm talking about. So this is the link to the data set. I will link this into the chat. As of now, there's nothing that you need to do. We will give you all the necessary items for you to be actually coding, but I just want you to have this link so that you can sort of understand what is going on here. The UCI Machine Learning Repository is a wonderful resource for any data set that you want to find. If you go on Google, search up UCI Machine Learning Repository, you'll find thousands of data sets just like the one that we're going to use today. And there's a lot of information here, which will also be going over in the lesson. And you can find the data here as well, but we will be giving the data to you as well. But here I just wanted to emphasize that the UCI Machine Learning Repository is somewhere where you can find tons of data sets that you can code in your later on once you learn how to do a machine learning project. So now we are going to talk about the information about the data set.
All right. So in this data set, just a few just a few things that we wanted to tell you about the data set itself is that it's publicly available. So it's from the website that Navia showed you, and it has many other data sets similar to it on that same website. And so this was created by Dr. William H. Wohlberg. And so we also want to check where these data sets come from, that they come from a reputable source, generally speaking, because if you use bad data, you're making a bad model, and that's never a good idea. So you always want to know where your data is coming from, that it's reputable and that it's good to use. And so the way that this data was created is that it used fluid samples and an easy-to-use graphical computer program called XCYT to perform the analysis of cytological features based on a digital scan. That's a lot of big words. Essentially, what happened is that there are a bunch of pictures that were taken of either malignant or benign breast cancer cases, and then a lot of different attributes were extracted from that using a computer program. And so it used a specific curve fitting algorithm, and we got 10 features out of this. And so each of the cells, 10 different features were calculated from the images, and that's the data that you're going to be using for your machine learning model. And so specifically the attribute information, first is the ID number. This will not actually be necessary for the machine learning part of it because the ID number is arbitrary. So you're also going to notice a lot of times that in data sets, there are certain columns that you will not use or you don't want to use all of them because you'll end up overfitting. And ID number is one of those situations where it's randomized and will not add anything to your model, so you won't use it. And then, of course, a very important thing is that we know the diagnosis. Since this is supervised learning, you have to know the diagnosis. And so every single row that we see, every single case, will be either labeled M or B for malignant or benign. And then we also will have 10 real valued features that are computed for each cell nucleus. So essentially, what we're doing here is we have those images that had the data extracted from them, and those original images were cells. And so what happens is that we get the radius, the texture, the perimeter, the area, the smoothness, which is just local variation in the radius lengths, compactness, concavity, concave points, symmetry, and fractal dimension. So it's not particularly important that you understand what every single one of these means, but these are all the different features that were extracted. And you'll notice in the data that it's not just 10 columns because we have the mean values and the standard deviations. So we have a lot of other data as well with it.
Absolutely. So before we go on to the next slide, what I'll be doing is I'll be sending the data set that we'll actually be using today. So I have just sent it into the Zoom chat. I will also send it into the WhatsApp for those of you who are unable to download it on the Zoom chat. So I've just sent it on the WhatsApp as well. And so both of those things, if you could download it, I believe on Zoom itself, the CSV file that I just sent, you can just click and then it will open it and it will save on your computer. Just make sure that you're able to see what's going on, like the numbers that are in that specific thing. So if you click to open, you should be able to see it. What I will do is I'll wait a few minutes and in the chat, if you could just give me like a thumbs up or telling me yes or like done. If you're able to see the CSV file and it's working, it's like an Excel spreadsheet and things like that. So just let me know if you are able to see it. So I'll give a minute on that. So just give me like a thumbs up, any sign that will let me know that you are able to access it. And what you'll see in that, just so that we know what we're looking at. If there's a question, you can put in the chat or you can let me know if you have anything going on. Okay, so we got one confirmation. If we can get a few more, that would be great, just so that I know if we have any problems. Okay, so I'll come back in like a minute and see if there's any updates. All right, so 1 minute. Make sure you open the CSV file and check that it's fully functional.
We have a question in the chat about naive bays. So what happens in naive bays if the weather changes? So that's a great question. What we would have to probably do for that is we would have to retrain the model according to the new weather changes, and that would change the original percentages, maybe from that 40% to 60% or to 20%. And so we would have to retrain the model with new data and keep an eye on these different weather patterns that are being experienced.
Yeah, absolutely. And again, the main idea of naive Bayes is to find the probability, right? So if there's a large probability that it is going to rain, then it's going to put that as a class. But if there's a smaller probability, like for the rain probability, then it'll say that it won't rain. And so, yeah, that's the main idea behind naive Bayes. Anyone who's unable to open the CSV file? And so, yeah, and once you open that and you're able to see it, then you should be good to go, and I'll let you know what you need to do with that. Okay, so what we'll actually be doing is using Google Colab. And because some of us have not been familiar with Colab, what I will do is I will send the link in the chat. So Google Colab, let me just send that into the link right here. Okay, so this should be the link for Google Colab. That should lead you right to, actually, let me send that again. Give me 1 second, guys. All right, so this is the link. This is the link that will probably lead you to the best version. So ignore that first message I sent, but that second message should lead you right to the Google Colab. And if you press on that link, you will see something like this. And if you haven't used Google Colab before, you obviously will not see any past projects like this, but make sure that you are seeing a screen like this. Okay, so just give me a yes or some confirmation that you are seeing Google Colab, because I know that some of you have not used Google Colab before. Basically, the idea of Google Colab is that it's a very nice way to be able to code without having to go through your terminal, and because it's harder to do that on in a virtual class. But usually what you would do is go through a terminal and then open like a Jupyter notebook file, but Google Colab is a wonderful way to get introduced to machine learning. All right, so give me a yes in the chat or a thumbs up. Again, yes, okay, done, all right. And then what you have to do is press new notebook right here. So new notebook, there's a button there. New notebook will basically take you to a completely blank file like this. So a blank file like this. And then you could rename your file to say breast cancer classification or whatever you want to call it. Okay, so I already have one open like this, so I'll just go ahead and go with this. But the main idea is that here you can add code by pressing this plus code here and code like that. Okay, I will zoom in a little bit so it's not tough for you guys to see. All right, so that should be much more noticeable to see. Okay, the first thing we have to do, however, is we have to make sure that the code or the CSV file that we just have is connected to this Google Colab. So what you'll do is you'll see these icons on the side, okay? And just let me know if there's any problems that you see here. So go to the side icons here, and what you'll have to do is press this file button here. So again, these icons, go to this file button. And what you want to do is upload the CSV file that you just downloaded. Okay. So what you'll do is to upload, you go here, this up arrow right here, press that. And what you'll see, you might see all of your files or anything, something like that. But basically you just want to take that cancer.csv file that I sent into the Zoom chat and the WhatsApp chat. And hopefully you'll see this in the drive of your folder or the drive of your, like the folder of your computer to the CSV. And all you have to do is open it or just double click on it. And you'll see this reminder, like reminder uploaded files will get deleted when this runtime is recycled. So what you'll see is that next week we probably have to do this process again. but it's just so that we can get started with this programming process and so that you can get familiar with it. So reminder, uploaded files will get deleted when this runtime is recycled. Just say okay. And what you should see is that you see this cancer.csv file right there. So yes. Yeah, so if you're not able to open a new one, there should be a file here and then new notebook. So that should open a new notebook for you. Okay, and then let me know if you're able to upload again. So without this, just so like when you open a new notebook, what you'll see is these icons right here. Go to this file looking icon right here, go there, and then you just have to press upload here. And then in your drive or folder in your computer, because you just downloaded CSV, so make sure when I sent it on the WhatsApp, when I sent it on the Zoom chat, make sure that you're downloading that CSV file. And then all you need to do is press on that and then open. And because I've already done it, I don't need to do it again. So yeah, the cancer.csv file should be seen on this left side. Okay, let me know in the chat. I'll give 1 more minute. Yeah, and so Sneha sent that CSV file in the chat again. So that's the one, it's the same one as I sent before, but yeah, if you missed it, you can click to download there. Okay, so I'll give a minute. Again, if you could just say done in the chat, I'll wait until I see a few done so that I know I can move on. Okay, anyone else? Let me know if you're done. Okay, it looks like there's a few people. Anyone else? Let me know if you have any problems in doing this as well, just so that we know that as well. Okay, there's a lot of other people here, so if you could give me like some sort of update, that would be great. Okay, all right. I guess we'll go ahead, just let me know. Okay, great, there's other people as well. Okay, thank you guys. All right, so again, just let me know if you have any problems. We will help you in solving them. Okay, so here we have a Google Colab. I'm just zooming in so it's easier for you to see. So we have a Google Colab notebook. And so what we can basically do in all of these cells is add some code, right? And that's obviously what we want to do. And just a basic introduction for Colab. Generally, for certain steps, you want to use different cells just so you organize your code. And so that way you can be able to see what steps you are exactly doing. So what we're first going to do is we're going to import some libraries. And so what we'll see where these libraries are going to be used later on, but we want to import these libraries so that we would be able to use the information inside of those libraries. So one library is more about reading files. One library is more about being able to calculate things, be able to find the accuracies and plot certain things. And then another is just easy for math ideas here. So what we'll do is I'll do a bunch of import statements. So import numpy, and then what you'll see here is as np, that's just a very nice abbreviation here. Then we'll also do import matplotlib dot pyplot, and then that will come as plt. I'll send these lines in the chat as well because these import statements are just a basic way to start off a machine learning project. And then we'll do import pandas as PDs. Okay. And also next week, when we continue with these projects, you should be able to go on Colab and Google Colab and see the project that you've been working on here. Okay. Okay, let me see if there's any problems. Oh, yes. Yeah, I forgot to mention that. Yes, you need to sign into a Google account to use Colab. Yes, you do. Yes, you do want to type this into your cells here because this is the way you're going to be actually using libraries in machine learning, and that's something that's just necessary for us because in order to use certain machine learning algorithms to be able to read files, which is what we're going to be doing soon with the cancer CSV we just downloaded and uploaded onto Colab. So yeah, all right. So now what we are going to do is we want to use our cancer data set. And so what we're going to do is we're going to basically read this file. We want to be able to read the CSV file that we just uploaded, right? And so the way to do this is we basically make a variable data set, okay? And so variables will hold this, the variable data set will basically hold the data set of this CSV file. And the way that we read this file is we basically say PD is representing the pandas library, which is great for file reading. So PD, because we just said made the pandas abbreviation PD dot read CSV. This is a function that will essentially take any CSV and just read it, right? It will store it into this variable here. And then read CSV, you put parentheses to put the input CSV. You might see something like this, runtime disconnected. All you need to do is reconnect. It'll still work the same. Whoops, I did not mean to do that. Okay, so dataset equals pd.read CSV. And all you need to do is put a single quotation there and then say cancer.csv. So if you check and make sure that you do have your cancer.csv file there, this should work, and we will double check soon as well. Okay, so when you run, just make sure that there's no errors that come up. So nothing will output right now because we haven't outputted anything, but just make sure that there's no errors. If there is an error, that means that you either spelled this CSV file wrong or you didn't upload the correct file. It could be any of those problems. So just make sure you uploaded the correct file and you've spelled the CSV file name correctly. Okay, what we're going to do next is we're going to define our input and output variable, define input and output variables. And so how we're going to do this, remember when we said input and output variables for training and testing data, we want the input to be all of the features that we have, right? So all of the features about let's say for this example, like age, and then like certain different features, right? All of these different features are going to be your input, but the output is going to be whether the patient has a breast cancer or not. And so we want to be able to define that. And so what you probably saw when you open the data set is that there's many different columns. So we want the columns that represent the features to be the X variable, which is the input. And the Y variable, which is the output variable, we want that to be the last column. The last column will tell you whether it's malignant or benign, whether they have cancer or not, right? And so what we're going to do is we're going to do exactly this. We're going to define the input and output variable. The way to do this is you use a function called iloc. And so what you're going to do, so iloc is basically the way of locating the columns that you want to define as X. So the way you're going to do this is you're going to do this specific sequence right here, and I'll explain what this means. Okay, and then you want to say dot values. Okay, so what you'll see is that there's a colon here, and then there's going to be some 1 to 31 here. What this will essentially mean is that you want all of the rows, and then you only want the columns up to that last one. You don't want that last column as X, right? You only want the rest of the columns. And then what we're going to do for Y is the exact opposite, right? What we're going to do, or like essentially the same idea, but we want to, so we still want all of the rows, but now we only want the last column. So that's what this means right here. 31, you just want that 31st column, basically. That's the column that will tell you whether they have cancer or not. And then here 1 to 31, the reason why we have 31 there is because 31 will actually not be included. It will only go from 1 to the 30th column. And so that's the idea that you have here. And then same thing, dot values. Okay, and then we'll look at what this actually looks like as well. So what we'll do is we'll just go do a quick like print Y, okay? Just a very print Y to output and see what this looks like. And so make sure that your output looks something like this. So you'll see and you'll be confused, like, what is this output? Like, this doesn't look right. But it's the classes of M and B, so malignant or benign, right? So that will basically tell you whether the patient has breast cancer or not. So these are, if you print Y and you see this, then you are on the right track. And if you don't see that, let me know, and I will send this code in the chat, because it's probably some typo that you have inside of these brackets right here, because that is very tricky to see. And let me know if you have any errors as well. Okay. And what I'll do is I'll remove this print Y statement. The way you could do that is just put a hashtag or pound symbol there. By the way, when I'm saying this, these are comments, right? So those are labeling our code here. Okay, Anishita, the problem inside of the code is, wait, let me check that. Oh, it says read.csv. So read.csv, you want to use a underscore. Yeah, so make sure you say read pd.read_cv, not read.csv. Yeah, so there's a, yeah, Python is very, you have to be very careful with your typing there. But yeah, otherwise I don't see anything wrong with your code. Yeah. All right, so hopefully that fixes that situation. Again, what Nishita did is great. Like, if you have any problems in your code, just send us the error and we can help you out there. And if we need more information, then we'll let you know. Yep. All right. Okay, so it doesn't seem like there's any other problems. So again, you just press this play button for running. And so right now there won't be any output because I just commented out that print, just so it's more organized, so that I don't just see a bunch of random M's and B's in the middle of my code, right? So just for organization purposes. All right, so now what we're going to do is we want to examine the data set. So let me just show you what I mean by examining data set. What we're going to do is we're just going to look at the first few rows of this data set. We want to see, what does this data set look like? Okay, so all I'm going to do, it's very easy line of code here. All you need to say is dataset.head and then parentheses. So that function will basically say, you'll see here, it just shows the very top part of the data set. So what you'll see, if I printed out the entire data set, it would be like a lot of different lines. But here, when I just said dataset head, it just shows the first 5. And I believe if I put something like 10 here, let me just double check that. If I put something, yes. So if I put some, just double checking there. If I put something like 10 inside of the parentheses here, so the default without, if I didn't put the 10, the default would just be to show the first 5 points of the data set. But here, if I say 10, it will show the first 10 points of the data set. So you'll see it starts from 0. So then it will go up to 10 data set. And so what will, sorry, not 10 data sets, 10 data points of the data set. And so what you'll see is here is that if I scroll around here, you'll see all of these different features. Again, as you mentioned before, it's not important for you to understand what each of these features means, as long as you understand that these are features. So and what you'll notice as well is we started from 1. The reason why we didn't start from 0 is because that's ID, like, you know how patients have ID numbers when they enter into a hospital, right? And so that information won't tell us anything about whether a patient's going to have breast cancer or not, right? So that's why we don't say 0 there. And so we start with 1 because we're starting with the important information. So radius, mean, texture, mean, all of these different features. And then what you'll see is that the very last column here is a diagnosis, right? And so that's why for X, we do not include that feature there. And for Y, we included just that last column. What to do after writing attributes? Okay, so in terms of writing attributes, do you mean like the defining input and output variables? So in terms of that, examining data set, the next sort of steps are more of like finding dimensions. So I will go over, actually we'll go over the formatting next week because they will take a little bit longer. But the main idea that we want to sort of show here, the very beginning of a machine learning project is just something very basic like this. You import some libraries, just define your input and output variables X and Y, and then examining your data set just to see what this looks like, right? You could have done that just by opening the CSV file, but it's nice to see in code here as well. So that's another thing that we want to emphasize here. And really quickly, before we end the lesson for today, we do want to leave you with a little bit of homework. And so what we don't expect you to code an entire machine learning project, of course, because we haven't taught you all of the different steps. But I do recommend that using this data set right here, we will give you a data set link right here. I will just link that here. Okay, so what we have here is a CSV file. And what I recommend you doing right here, what I recommend you doing is try to do everything we've just done right now with the defining X and Y, examining the data set, and try doing that with this data set right here. And we'll actually give you some help because we know that this CSV file is a little bit different from the one you saw before. But these are the 3 lines of code that you want to implement to basically read the file. What's interesting about this CSV file is that it automatically, like the CSV file we had for the breast cancer data set, it automatically gave the columns. But unfortunately, sometimes when you look at data sets, they won't automatically give you those columns and they expect you to sort of code that yourself. So the way you need to do that is you need to say these names right here. So these are the column names we want. And then inside of the read CSV, you want to give the URL. The URL is what I pasted into the chat just now. So make sure you save that URL and we'll send it to you if you lost it in the middle of the week. And so this is the 3 lines here. This is just so that you know how to read the data set. But after that, everything that we just learned today, like defining X and Y, make sure you look at the data set and see what do you think is the X values, what do you think is the Y values, how would I define it? Again, there's not going to be 30 features in this data set, it's going to be a different number. So you want to make sure you can go around that fact as well. Again, we will go over the solutions to this project later on. We will be teaching the entire breast cancer classification project before we go over this iris classification project. But I think it's a fun way to get started on your own with exploring how can I use what I just learned today with the examining the data set and defining X and Y, and then sort of putting that into code here. And so what's interesting here is that for this URL data set here, you actually won't need to upload a CSV file on Google Colab, which is very convenient because all you need to do is say this URL and it should work that way as well. There is a question about import file, how to create import file. I believe you are talking about the part here where we have to do this, or is that, yeah, so how to create an import file. So if I'm not mistaken, just make sure you go to this files icon right here, press this upload here, and you should be able to upload a file like that. If you're talking about something else, make sure, like if you want to save a certain notebook, you could save a copy in Drive. You could put in GitHub, you can save, like there's a lot of different options here, open, upload, notebook, all of those different things. Okay, should we import libraries for this? Yes, so that's a great question. For any machine learning project, these are the main libraries that you want to import. So like you want to import these 3, like put these 3 lines at the top of machine learning projects, just because it's a standard practice that you're going to be using these libraries later on in the code. So today what we only use this pandas library, right? And so there may not be any need for you to import these 2 right now, but it's standard practice and I would recommend you do it anyways, just because later on it's easier to be to import it, and other than like going through all the code later and then realizing why is my code not working and then you have to import it again. So yeah, I would just recommend importing these libraries here. All right, any other questions? It doesn't seem like it. All right, so we'll go ahead and conclude class for today. So today we went over a lot with the finishing up the machine learning algorithms from last week, and then doing a little bit of steps for this breast cancer classification project. So I hope you all enjoyed this class, and we'll see you in the next class for the continuation of this breast cancer classification project and going through its entirety by using machine learning algorithms and seeing its accuracy against test data, like splitting training and testing data. It'll be extremely fun, so make sure to come to the next class, same time, same date, and we'll see you then. So thank you, everyone. Let us know if you have any questions in the WhatsApp chats, emails, anything like that, and we'll be sending the recordings as well if you need to check back on anything. All right, yes. Google Colab automatically saves projects, which is wonderful. So next week when we do this project again, all you need to do is go to Colab and then go to your past projects and you'll see your project right here. Just press on that and then we'll be continuing on with our project. All right, thank you everyone and see you next week. Bye-bye. Thank you, have a nice day.